Hello, in this video I'll show you how we can start learning R. Okay, hello guys. In this video I'm gonna show you how we can start learning R. Let's start by introducing what is R. R is a software package especially suitable for data analysis and graphical representations. Functions and results of analysis are stored as objects when you have already done some sort of calculations, issues of analysis. So all those informations are stored as objects, allowing easy function modifications and the model buildings. R provides the language tool environment in one convenient package. Excellent graphical tools maker. R also is an ideal environment for exploratory data analysis. So without wasting our times, let's start by working on R. Let's start with simple basic operations of R. The basic operations that we see is just like addition, subtraction, multiplication, and division. So let's start by doing the combinations of those computations. Suppose I want to compute this one, 2 plus 3 times 5, put brackets, then divide by 4 minus 13. What you're gonna get? You get 0.33333 and the others. This is how R is used as a calculator to solve different operations, and it is solved according to the order of operations. That is to say, body mass. Now we can find sometimes maybe the logarithms. Maybe we can find the log of 10. The log of 10 is 2 point that one, and that one. But this is just a logarithm, but it takes base as 2.7188282. That is the meaning. So if you want to solve it in base 10 logarithms, if you want to solve in base 10 logarithms, you have to take log of base 10 of 10, then you get 1. I think you have already now know how it works. If you just like log, you just write log of a certain number. It takes a base e, which is 2.7188282. But if you specify that it is base 10, then it will solve according to base 10. Suppose I want maybe to solve another log of 100. If you just like 100 like this way, you see it is 4.60 in the other numbers, but that is according to base e. But if you want to solve the common logarithms, base common logarithms, base 10 common logarithms, now you have to put a base 10 out of 100. Now we know this is what? This is 2. Again, log of 1000. I'm sorry. Log of 1000. If you have misplaced some words, we just use the arrow keys, going forward and going backward, going up and going down. Then just press OK. That is 1000. This is according to base e, because we are not specified the base. It is 6, but if you specify the base, that is log to base 10, then it will be very simple for you to get 3. Maybe let's check for power. Suppose I want to write maybe power for power 5. What do you get? You get 1, 0, 224. Let me check for division. 3 divide by 3. It is 1. Then find the square root. This is just basic. That's why I'm very fast, because I know somehow you have some background knowledge concerning this one. So this is according to simple algebraic and simple operational and simple basic operational computations, and you can do as much as you can. Okay, let's go on maybe by finding the absolute of a number. You just like abs of maybe 3 minus 10. Okay, you get 7, because we know that the absolute, whenever number is in the absolute, when it comes out it is positive. If it is positive, when it comes out it is positive. If you get 3 minus 10, which is negative 7, but when it comes out of the ABS it has to be positive. Okay, let's find the pi of a number. Maybe want to find maybe a pi of let's try to check this one. What's the value of pi, man? The value of pi, it is 3.14. As we know that it is 22 divided by 7. So if you just like pi, it gives you such a kind of a number. Let's find maybe the exponent of 2, exp maybe of 3, exp of 3. We know it is 20.0855 4. We can go on again finding other exponential functions. Maybe exp of 2, you get 7.3 and the other numbers. Okay, suppose now we want to find maybe the modulus, maybe 15 modulus of 2. Okay, an expected error in this one. Maybe this one, let's try to take it again. Try to use this number. Good. Let's take this way. Let's take this way. 15 divide by 2. We know it is 7.5. Now we take 15 modulus of 2. Let's check this one. Okay, unexpected error for modulus. It's not an issue. Let's go forward. We will come and check. But what I always wanted was check the modulus, if it can find the modulus. But you have to put some programming so that it can solve such a kind of a problem. We will check it as we go on. Okay, now let's check some symbols, which call it as an assignment operator. Assignment operator is used as an equal sign. When you want to assign a number, maybe x is equal to 5 plus 7. So in order to connect with x and 7 plus 5 or 5 minus 7, it should be connected by an assignment operator. This assignment operator is an equal sign. Okay, suppose I want to recall maybe this number w. Instead of putting equal, we just use this symbol. This is an assignment operator, that W is equal to, you put the bracket here, or instead of putting the bracket, you have to assign C for binding. Then you can take 5 minus 7, then you press enter. If I recall the W, then I will get the 5 minus 7, which is minus 2, which is minus 2. This is an assignment operator, and this is how it is used. Okay, let's go for vector operations. For vector operations, we can assign some numbers as I have used the above one. Maybe let's use now another number, maybe A. A is equal to, you have to put this C for binding. Then the kind of vector that I want to be displayed, maybe it is from 1 to 10. Then I just write 1 colon here up to 10, then put bracketing. When I press enter, it goes to another line. Then I have to recall A, so that I can display all numbers from 1 up to 10, including 1 and 10 itself. If I press enter, then you see it is 1, 2, 3, 4 up to 10. This is how array is used. Okay, but you can also store different numbers. Maybe let's use now Z. Let's use Z. Okay, or maybe let's use V. V is less or equal to, sorry, I have to put C for binding. Now I will write different numbers, not in a chronological order. Maybe 1, 4, 5. We separate this by commas. You have to know this, and don't. Okay, maybe 45.78, then put the bracket. If you press enter and recall the value of V, then all numbers is displayed. It is displayed according to decimal places, because already some numbers in these brackets are in decimal forms, so all numbers should be displayed in decimal forms. That's how ARA works. This is how ARA works. Okay, you can do a lot of calculations, scalar multiplications, scalar additions, scalar subtractions, and other manipulations. Also, you can find sometimes the length of the number. Suppose you have this kind of numbers, maybe let's put this way. Suppose you have this number, maybe D is equal to C. Now take 2 up to 45, put bracket, then find the length of D. Find the length of D, then it gives you, it is 44. That is the length of D. It means from 2 to 45 there is 44 numbers. That is the length. That is how the length works about. Okay, now sometimes we can manipulate the subset of a vector. Suppose I have this vector, that is F, what's my name, is equal to C, put the brackets there, and maybe I have this number 1, 3, 2, 10, and 5, put the brackets. then write what is the value of f. What's the value of f? It's from 1, 3, 2, 10, and 5. Now I want to extract some subsets from that vector from 1 to 5, but between there is 3, 2, and 10. What I can do is just like x. Be careful there now. I put this square brackets, and I want to extract from 3 up to 5. Then I put this one. From there now you have to write the enter. It says that object x not found. You know what? I have included x while my number I stored as c. So I have to write f. I'm sorry, I have to write f. Stored as c, so I write f. So brackets, or sometimes you just do this way, record this one, then come to here, take f, then press enter. You see now you have obtained 2, 5, and 10. So I extracted a subset of number from 3 to 5. So only 2, 5, and 10 has been taken. 1 and 3 remain. I can also extract other numbers, maybe from 1 to 10. Then it will be taken 3, 2, and 10. So just write f square bracket, take 1 up to 10. Okay. It says that it is 1, 3, 2, this one and the other applicable, not applicable. Okay, whatever the case, but this is how it works. Okay, now from there, sometimes we can store characters, not only numbers. R sometimes is used to store characters, but you have to put apostrophes, double apostrophes, used to store text, used to store a lot of things. Suppose I want maybe the colors. I will take it colors. I will write in this form, rename by colors is equal to what is C as a bind. Then you have to use this one. Maybe I have green. You have to take this one. Then another color. Now we have red. We have blue. Yellow. And the other colors around. We have a lot of colors, but let's take this way. Okay, now you press enter. If I like colors, I'll call it, then I get those kind of colors. This is how you can store the character in R. So R accepts numbers as well as characters, but those characters, and sometimes numbers can be considered as characters if you put those double commas or double apostrophe. If I write these numbers, maybe let me assign G is equal to C, then put bracket, and let me take this 34, take 56. Okay, let's take 5 now because it is already been written by itself. Take another number 6, and then put the bracket. We call the number is that one. Now we have written numbers as text. Now from those numbers 34, 5 and 6, you cannot add, you cannot multiply, you cannot subtract, you cannot divide, because it is you have already specified it as a text. So no mathematical manipulation can take place. Okay, we have seen vectors, we have seen the basic operations. Now we have seen how we can store characters. Okay, now let's take how we can construct a vector or a sequence of a certain patterns. The verb that is used for constructing a sequence of a certain number is called seq. That is SEQ. Okay, SEQ. Suppose I have this vector 1. Let me take now y is less equal to C. I'm sorry, I have to put this one. Now take maybe 3, 5, 1, 5, 6, 7, 3, 4, 9, 8, 7, 2, 11, 12, 12. Then press enter. Then recall the value of y. You see, it has been written that form. Now I want to put it in a sequence form, just like sec of y. But it can tell me anything, because y is not a number. Okay, it has come in the same way that I was thinking. Now you see, from 1, 5, 1, 3, 6, 7, 3, 4, 9 and other things. Now I have written the sequence of y. It is started by writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is written this in a sequence. If you come to these numbers, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And if you come to the second values, which is the sequence of y, it counts the same number from 1 up to 13. What it considers the counting process, not the number that it's been written. That's why you see now here it is 13, because the total number from this value it is 13. That's why it counts from 1 up to 13. That is how the sequence function is using or is being used. Now let's see how we can input matrix into R. That is matrix operations. Okay, suppose I want to write what you have to know in a matrix, please. You have to know the number of columns and the number of rows that you want to write, or you want to put any R, or you want to make some multiplications. If it's two matrix, maybe you want to multiply or you want to add. If they do not match, it means you will get any error results, because when you add matrix, when you multiply matrix, when you subtract matrix, orders are much considered. So you have to be at least have a knowledge of matrix, then you can do what you want on the kind of manipulation you want to make. But let's start by checking this one. Suppose I want to enter into R my own matrix of this number. I term it as don't assign a number that R use it as an object functions. Suppose if you try to write matrix to your storage object, it will not function. To give you, it will give an error because already there is an object functions of matrix in R. So if you want to assign it with different names, you cannot assign, maybe sometimes using sum, you cannot assign for sum, you cannot assign for mean, you cannot assign for anything. That's why I'm using K, I'm using F, I'm using D, I'm using SA, I'm using anything. You can use sometimes a name, your name. Okay, let me start by, maybe my name is Ben. Okay, my name is Ben. This is my matrix. So I'll put an assignment operator there, write C. After writing C there, then I have to put, instead of writing C, I'm sorry, you have to put your matrix. Then after putting the matrix, then you can put a brackets and write which bind, that is C. Then how many numbers you want to appear in your matrix. Maybe you want 2, you want 3, you want 2, maybe 5, maybe comma minus 1, maybe 2, 2, 4, and now after writing those numbers, you have to close it, because this tells you that your matrix includes this kind of numbers. Then from there, put a comma. How many number of rows do you want your matrix to be? And how many number of columns do you want your matrix to be? And another things, in which ways you want your matrix to be filled, column wise or row wise. That's what you have to consider before putting your matrix into our package. Now suppose I want the number of column to be 3. You just like n col is equal to 3. That's the number of column. Then there is no need to specify the number of rows. By default, it will be displayed. Then you want to fill it by row wise, then you just say by row is equal to true. By row is equal to true. Then you press enter. Okay, then if I write Ben, then my matrix will be displayed. Okay, I think we are going together. I think we are going together. Okay, now from here, let's end at this point. Then we will continue on the same issues until we complete this program of R. From these tutorials, as I have studied from the beginning, I want to complete all basics of R from beginning to advanced level, so that any problems, any analysis concerning with your projects, you have to use R programs or R package, because it is a very good software for statistical analysis. Start by looking these issues, then we will go forward until we complete these tutorials. Thank you and see you in the next lesson.